As cities, workplaces and homes increasingly adopt the Internet of Things to improve efficiency and quality of life, vulnerability to and impact of cyber attack increases. Growing reliance on data, often generated by Internet of Things or IoT sensors, leads to a continuous rise in data compromises. The pervasive nature of IoT in public spaces makes trusting it essential for societies to operate effectively. Threats against availability, such as distributed denial of service, now rank as highly as ransomware in a NISA's Threat Landscape report. Attacks are getting larger and more complex, increasingly involving IoT, with public administration and the general public targets of 37% of incidents. NCSC warns smart cities collecting and storing sensitive IoT-generated data are desirable targets for cybercriminals and attacks. Effective and resilient cybersecurity of IoT-enabled environments is crucial in protecting the privacy of our personal information, maintaining safe infrastructure of our cities, and protecting against cyber attacks. Here are some ways Petras research is addressing these challenges. Res-B. Smart built environments are heavily dependent on IoT systems to reliably sense and monitor their surroundings. However, they can become targets of malicious actors, creating significant, potentially catastrophic, even fatal risks. The Res-B project explored how to add layers of resilience to smart home and office environments, reusing and repurposing existing resilient sensing techniques identifies malicious activities by detecting anomalies in cyber-physical environments. The project seconded Dr. Charith Pereira into Building Research Establishment, BRE, to explore resilience from a holistic viewpoint of smart office and smart home environments. With BRE, Dr. Pereira and his team developed a research agenda combining academic and industrial need. They formed a better understanding on how to develop and use smart homes IoT infrastructure to gather and analyze data concerning malicious activity and anomalies, and built a new smart home testbed at Cardiff University. Such understanding and infrastructure helps to advance and test novel cyber-physical anomaly detection techniques, better protecting future smart homes. PT Heat. Today, thermal cameras can be bought online for less than £200. Despite many benefits, they present a new front for side-channel attacks, such as taking a thermal image which reveals heat traces left on keyboards and touchscreens, revealing the user's input. These are referred to as thermal attacks. Previous work on thermal attacks focused on understanding the viability of the threat or developing basic solutions. The PT Heat project is the first to investigate solutions targeting prevention by developing a deep learning-based framework that detects user interfaces in the feed of thermal cameras, then obfuscates the interface. The PT Heat project adapted 3 state-of-the-art object detectors, FasterR CNN, SSD, and YOLO, to detect vulnerable user interfaces in the feed of thermal cameras. By implementing multiple methods for obfuscating the heat traces, PT Heat's achievements include a publicly available dataset and machine learning model, and delivery of open-source, deep learning-based software through a web application and codes, currently being ported to work on thermal cameras directly by project partner Census. Priv IoT. The UK government is targeting a complete rollout of smart meters in homes by the end of 2024. To ensure efficient power usage, rollouts of automated demand-side management, DSM technologies, will follow the trials currently taking place, in which customers receive rebates for using energy at a time of lower demand. These technologies offer important functionalities for the national grid and economic savings for citizens by tracking the activities we carry out in the privacy of our homes. When further integrated with consumer IoT devices, the interactions between them, smart meters and DSM, could result in a multitude of digitally enabled harms. It's crucial to understand these potential harms, especially as we're spending more time at home. The Priv IoT project has worked with Toshiba to explore this and delivered a systematic review. It found current research to be focused overwhelmingly on technical solutions over environmental conditions, social awareness, and behaviour of device users and attack perpetrators. The project team then took a citizen science approach to understand how threats and opportunities can be communicated and visualized, developing conceptual tools to improve users' situational awareness and agency. Explore our expansive knowledge base of cutting-edge socio-technical IoT cybersecurity research findings and over 470 research publications on the Petras website, petrasiot.org.